Hello, good afternoon, good morning. We will get started a little bit after the hour just to give folks some time to wrap up meetings before and trickle in. Good afternoon, good morning. We'll get started at about 5 after. Just give some folks some time to settle in. We'll get started in 1 minute. While we wait for folks, can I get a thumbs up from the audience to make sure that A, you can hear me, and B, you can see a Google Slides on the screen? Beautiful, love it, great. Thank you so much. We'll get started in a minute. All right, we're 5 after. That feels like a good round number to kick things off with. So first and foremost, welcome to our webinar. We're really excited to spend some time with you today and very excited to talk all things speech to text. By way of introduction, my name is Garrett Van Arkel. I've been part of the Corti team for a number of years now, and I work with our activations team. So that means if you've written into our help kind of email address, visited our help center, booked a scoping call with us via the website, you've worked with one of my teammates. I'm joined today by Dan Engel. Dan's a principal product manager at Corti, and one of his many areas of expertise is our speech to text stack. So before we get started, a little housekeeping. First, if you've joined us for previous webinars, you'll notice that we're using a new webinar tool in this session. While you can see and hear us, we can't see or hear you. We still do want you to be involved, and we still want to hear from you in the chat. So by all means, use those react emojis. We're going to keep our eye on the chat. That makes it a whole lot more fun. Second, we are recording this webinar, and we'll be able to share the recording after the fact. So if you have any colleagues who couldn't make it, you can share that with them. With all of that done, let's get into the agenda. So our plan for today's session is to start with a lay of the land of speech recognition and in particular dictation today. Why is it so important? How do some organizations solve for that speech to text layer? With that basis of understanding, we'll then walk through the results of our recent release, Symphony for Speech to Text. Dan will review important concepts such as word error rate, medical term recall, and formatting recognition. We've done a ton of testing on the models, and we're quite proud of those results. From there, we'll talk about how to use Symphony for your speech recognition needs. Again, we'll take a special focus on more dictation style speech recognition, but the model can be applied to so much more than just that dictation workflow there. We'll walk through the available configurations and share some considerations for how to set that up for your various use cases. Lastly, we'll end with sharing some lessons in evaluating the quality of speech to text. As you know by now, Corti is rooted in research, and we want you to be able to test us on the results firsthand. It's not an easy thing to test, but we'll share tools, methodologies, and make sure you feel equipped to show the accuracy of your own tools that you're building. As I mentioned, we want to start with a picture of speech to text and dictation today as it relates to clinical workflows. It's not remotely a new concept, right? Going back over 100 years where clinicians would have human scribes in exam rooms to document on behalf of the clinician. That moved into physically recorded dictation tools where speech would be recorded on like tapes to be transcribed by a human later. In recent decades, that's become more scribing software solutions that have replaced a lot of those legacy dictation workflows. So regardless of how that audio is captured, the fact of the matter is that the vast majority of clinical documentation originates from speech. That could be the dialogue between a patient and a provider, dictated notes, transcripts from telehealth visits, and so much more. Speech is everywhere in healthcare, and capturing that speech and turning it into text allows for both more accurate documentation as well as supporting downstream workflows to capture that information in that speech. So just take that speech and turn it into text. It sounds pretty easy, right? But as we all know on this call here, it's not quite that easy to do, but you all know that, right? Now I won't sit here and read off every single item aloud to you, but a few of the factors that make healthcare as a language really difficult include really the breadth and complexity of the language. So as you're seeing on the slide, right, SNOMED CT alone has double the number of concepts as the number of words in the Oxford English Dictionary. That's a lot of words. It's also multimodal, right? A clinician will bounce from numbers to abbreviations to acronyms to codes, and that's just in one sentence. The variance in what they're talking about and what is being communicated makes healthcare incredibly hard to transcribe. And lastly, doctors are people, and communication can be different across people. Am I highlighting this because maybe I'm teeing up a feature that Corti has that I'll talk about a little bit later? Maybe. But it remains true that communication styles are different, and that makes recognizing speech that much more difficult across a broad provider group. So that brings us to the market today. When you look at speech recognition solutions on the market today, you can quickly start to break this down into quadrants. So I'm going to first start with hemispheres, and that'll explain maybe more of those quadrants. So those first hemispheres that we're looking at are point solutions versus API first solutions. Those point solutions are wrapped in apps, right? It's something that you can download or log into and then quickly use as a provider, and that's ultimately what that point solution looks like is more of an application. They're applications that providers use for speech recognition in their workflows. Those API first solutions aren't always wrapped in apps and maybe require a few more steps to be able to take that speech and turn it into text. But the output is very much the same as with those point solutions. The journey might be just as slightly different there. The other way that we'll segment in speech recognition solutions, it's focused on the industry and specialization of speech recognition. So as we learned from the previous slide, right, healthcare is hard for speech recognition. So on the bottom half of this graph that we're seeing, those are more of those generalists. They have more general models that can be applied more broadly, speech recognition, to many fields, including healthcare. On the top half, you'll see more of those specialists. This is where applications and models are focused on the specialized language of healthcare. So in the speech recognition specialization track, we now have those 4 quadrants, which is where Corti distinguishes itself. We specialize in healthcare, and we're API first so that the builders can build using specialized models in healthcare. A few things that are important to note before I kind of move on from this. The chart itself is very focused on more of those dictation workflows. Many organizations joining today will be building dictation into their applications, but you'll also have more use cases in your applications. That could be more workflow tools, that could be agents. There's a lot more that could be built. This is very much more focused on those dictation tools. The last thing that I want to kind of put as an asterisk is the chart also somewhat omits some of the detail in availability across region, language. As we saw with open evidence recently, some organizations are not as bullish about the more regulated markets like in the EU. Corti has language suite that supports 90+% of providers in the EU and the regulatory certifications to support it. And with that, I'm going to pass things over to Dan and let him introduce Symphony for speech to text.
Awesome. Thanks, Garrett. Appreciate the introduction on the background of dictation and speech recognition in healthcare. And we are very excited today to present to you, and last week having launched our Symphony for speech to text. Symphony, of course, is the flagship clinical AI model that Corti released in January of last year, as when we first launched it. We had a few launches on our platform this year following that big platform announcement. And since that time last year, for speech purposes, we've been refining all of the speech and audio data that we, as a company, have collected over the last 10 years, looking back at our legacy businesses and even into where we are today as an API platform. But we also combine all of our own data that we've captured with other public and private sources to fine-tune and improve our models for wide general purpose use across healthcare. As Garrett mentioned, we want to enable you to build dictation apps, but we also support ambient conversational audio, as well as traditional transcription based on audio files and supporting other types of emergency calls. And so the launch from last week of Symphony for speech to text, we included a benchmark paper that summarized performance across all of those needs. And today we'll go through some of those results to help make sure the finer details from the paper make sense. And then, of course, please, as Garrett mentioned, write in with questions and let us know how we can make sure we connect the dots for you. While the basic concept, of course, is to match the most statistically probable word for a given audio signal, as you see in that lovely little graphic, there's so much more to it than that. And you'll see that we've described a pipeline for audio processing to get to the best possible result given those workflow needs, and to make sure we balance all the complexities of medical language as Garrett summarized on some of those preceding slides. So if you want to go to the next one, we can go one level deeper into what is Symphony. And so, what is Symphony for speech to text at least? And so Symphony being our clinical grade AI model, it sits underneath of an API accessible platform. And for speech purposes, we have 3 endpoints that you can use. Transcribe and Streams are both WebSocket based real-time workflows for processing on a live connection. The key difference between the two is that Streams is stateful. The content that the audio that you're streaming and the content being generated is associated with an interaction, which of course can support a variety of purposes, but the most simplest connection is to an encounter, whether it be inpatient or outpatient. You can associate all the assets of that encounter as part of an interaction, same concept there. And that could be audio, transcripts, facts, notes, etc. Transcribe, however, is meant to be stateless. It provides very easy access to dictate and use configuration to decide what your formatting and style preferences are as your output. And this is meant to be very, very lightweight and easy to implement and flexible for where and how you use it. Instead of having to associate the audio and the content that's generated with an interaction, it's more freeform and available when you need it, and then you can disconnect and be done and not have to worry about that data persistence on that connection. Transcripts is a little bit of both, where this is then audio file-based processing, so it's accessed through a REST API, and provides a synchronous to asynchronous experience for real-time processing or getting your results after the fact. And then on the bottom part of this graphic, you see the pipeline aspect. And so while the middle box, diarization to separate speakers and identify participants in a conversation, if you're having conversational audio, and then the transcript creation itself is what we think of primarily when you think of speech to text and speech recognition. There's also a lot of logic for ingress and managing network traffic and routing to the appropriate services and handling configurations and scale and so forth. And so as the platform service provider, this layer is just as important as the transcription itself so that we can service all of you on behalf of all of your customers and make sure that we have that regionality available. As Garrett said, we offer services throughout Europe as well as US, and we have some use also in Australia and New Zealand area. So we're looking to expand across the globe, and we have nice ability to deploy regionally as we need to and make sure we adhere to all the compliance guidelines. But the bottom box is also not to be forgotten. And to try to do all of the formatting and styling of the text at the same time as recognition makes it very challenging to support a variety of workflows. And so we have some examples of that we can talk about. But here, if nothing else, it gives you some control and configuration power over how you want to experience the output. And the result of all of that is that you get this nice structured transcript as an output. And then depending on your workflow need, you can control what that output looks like in the structured transcript. You can go to the next slide, please, Garrett, and we can start talking about some of the results from our paper. So this is one of the figures from the paper, and it summarizes all of the word error rate results. And I know there's a lot of numbers on the slides, and it's probably hard to see. So it's a screenshot from the paper. You're not missing any data or details that you don't have access to. And we have a couple breakouts on the following slides. And so in this benchmark paper, we wanted to write about and document and communicate the way that our system is performing compared to other industry-leading models. And so in the paper, we describe our methodology where we had a selection and screening process where we used our own internal tools for measuring, I think, 8 different vendors we looked at. And we ultimately landed on 4 that we went very deep on the analysis on. And so that's where we had Google, AWS, and OpenAI. And then we also used 2 open source models of Parakeet and Whisper as high performing, well known in the industry, and a way to understand kind of baseline of what an out of the box open source model can do as compared to these closed source proprietary models that are household names, of course, that everyone recognizes between OpenAI, Google, 11 Labs, AWS. And so when we did these analyses, what you'll see in the paper is our benchmarks focus on medical performance, but we also look at general recognition and use a data set that's very well known in the industry called Common Voice for evaluating how we do on just general speech to text to make sure that we did not overfit our model and go too far on clinical terminology training. And that's especially important when you want to use this for conversational ambient scribing or other purposes for telehealth, et cetera. And if you overfit the model to one purpose, you're going to degrade it on other areas. And we did see that in some of the models. For example, with Google, we saw that their medical model is very, very overfit for medical performance and greatly degrades its ability to support general conversational, whereas the Google non-medical model does great with conversational, but performs poorly on the medical data sets. So it was almost like they have 2 completely different models for different purposes. 11 Labs, we see they do very well with conversational audio, but really fall down on some of the medical terminology that we threw at it. And, the Parakeet and Whisper model similarly were trained on vast sources of general purpose conversations, but were not trained on medical dialogue specifically. And so that's where, as part of this process, we realized there are no robust medical terminology evaluation data sources. And so we plan to be contributing and publishing the data sets that we used for this trial. Firstly, we used one called MedTerms, which is 10 hours of audio representing thousands and thousands of different samples with over 150,000 medical terms included in it. This is our large validation data set that we use for all of our model fine-tuning evaluations. And so we'll be publishing a subset of that for the industry at large to use, to test with, to recreate our benchmarks. And we want to continue to further everyone's efforts in the industry. And to complement that, we also have a data set called MedDictate, which is 2 hours of specially curated dictation content for longer form front-end speech recognition with formatting and punctuation included in the evaluation, very similar to how you would use and evaluate a front-end dictation system like a Dragon Medical One or an M-Modal Fluency. And so the difference between these two is that MedTerm is focused on the terminology itself. We're not looking for punctuation. We're not evaluating for formatting. There, the data set is normalized, and the evaluation as a result is also normalized. And so in these detailed statistics, that's why there's so many rows there. Word error rate, you're looking at the numbers themselves, the words themselves of how they're recognized, making sure that every substitution, insertion, and deletion is identified. But then there's other more specific measures for recall of medical terms, recall of punctuation, and precision for punctuation and for medical terms. And we look at both sides of that detail of recall and precision, because if you miscapture the word colon, that might be a false positive for medical terminology, or a false negative for punctuation, or vice versa. So we look at that level of detail, and we don't roll it up to an F1 statistic, because we want to see it specifically what was right or wrong for every measure, and they're almost complementary in some ways. And so by separating those punctuation from the terminology, we can understand how the system does overall across both different sorts of data sets. And so here in this graphic, we're looking at that key term precision. But then in the paper, you can see the breakout of every individual study for both the MedTerm dataset and the MedDictate datasets. And in the week ahead, I think if not this week, then next week, we'll be publishing some of those datasets for use and through Hugging Face. So you'll be able to get access to those. And I'm sure we'll be sharing the links on our socials and on our website. Can you go to the next slide, please? Perfect. So then looking specifically at the word error rate, the statistic we were very excited to see and proud of is that 1.4%. So this was the word error rate that we had measured. Of course, word error rate being the most commonly used statistic for evaluating of speech-to-text systems. This is based on that normalization where everything was lowercase, no punctuation, and this is over the thousands and thousands of terms that are in that MedTerm data set. We saw that this was consistent for both real time. So we tested for all these other vendors. We tested both real time streaming and batch audio file processing and used as consistent of a practice as possible. Corti at its core and our background is a research organization. So we definitely were very methodical about that piece of it. And again, encourage you to engage in the details of the paper to see what was done. And then in a couple slides from now, we'll talk about how to do evaluations properly. And that level of detail, that orientation is super critical for accurate and fair evaluations, but then also truly understanding what's going on under the hood and behind the scenes. Next slide, please, Garrett. So then we can go into beyond just the speech to text. So what about formatting? And formatting matters a lot, right? When you're building a dictation system, it is not just raw speech to text. And there's a difference between what is sometimes, at least in many scenarios, a difference between what is said and then what's expected. And the more that the speech to text engine and pipeline can handle itself in terms of formatting, then the less you as the integrator need to build into your speech to text integration and deployment. And while we saw, some of the systems like in 11 Labs or OpenAI, they might do very well with the raw speech to text, but they have no ability to configure and handle the formatting. So that means that on your side, you'll have to be setting up abbreviation handling and measurement handling and date formatting and numbers, et cetera. And on our side, we handle dozens of those different measurements. And we have options and configuration for dates as numbers to give you control over that style and experience. And of course, you will likely find that differs not just by site, but by physician, or maybe even within a physician, one case to another, they might have differing preferences. And so giving you control over that at a configuration level, but also building a lot of it into the system at its core has allowed us to exceed the other vendors in performance on this statistic as well. The last piece of this, I think that probably matters most, is the key term recall. And while overall word error rate is interesting, it doesn't give you that visibility into which errors matter the most. and missing an article, or if there's a disfluency, a hesitation, like I've been doing as we're talking here, stutters and stammers and ums and ers, if those are transcribed, those will all contribute to word error rate, just the same as misrecognizing a medical term. And so word error rate is a little unforgiving in terms of overall looking at any error that is made in the note. But medical key term recall allows you to see how well do you perform on those terms that matter the most. And so for this, we also came out on top, correctly recognizing the most complex of clinical terms that we were throwing at the system. And on our side, we continuously expand our core vocabulary with every round of our model fine tuning. And anytime that we work with a partner and a customer and we collaborate on an evaluation, there are times, of course, that we mistranscribe a word. It didn't recognize it in that context, or it didn't recognize the way it was said and how it sounded like. But there are some times, that we see that there's a word that the system was not exposed to. And every time we have that, we are adding it in. And frankly, in my career, this is the fastest I've seen the machine learning team be able to turn around a model, and we're turning around models every 2 to 4 weeks. So it's been quite rapid for iterative improvement and allows us to very quickly identify and respond to issues and make them available across the stack. Next slide, please. So the last measure we'll have here in this section, and again, we'd be happy to go into more details in the paper and talk with you about every measure that's in there, but there are too many to go through in one webinar. But to complement comparison to the API first vendors and what you can build yourself as an integrator, we also wanted to compare it to Dragon Medical One. And honestly, this is not the first time in my career that I've worked on a speech recognition tool going head to head with the legacy giant. But the approach and the performance that we've taken here is different than my past experience. And, of course, DMO, it continues to perform well on all types of medical dictation. We did find some edge cases in complex or uncommon terminology, some different formatting preferences for abbreviation and compound word handling that are, you can maybe flip a coin or argue on which is correct, but, we'll go with what we think is grammatically the most correct. And then, of course, the last piece, the most important, is flexibility and customization for your integration and use that DMO wouldn't offer. And so here we see that Symphony performs as well or better than DMO. And I think, there are cases where we exceeded. There were some cases where DMO was equivalent. There were some where DMO was better. But over those whole data sets is where we saw that we had a slight edge. And I think that this shows Symphony can much more easily than the other vendors that we evaluated be used to build a DMO replacement. And that's because I think of not just raw speech to text accuracy, where we were a top performer, but also because of all the formatting and customization and measurements and so forth that are handled. We put a lot of focus and attention on to what is needed, not just for speech to text, but to speech enable a clinical workflow and to support legacy dictation for functionality as well. And that's when you get into the functionality of the API beyond just that speech to text, to be able to configure commands and measurements and date formatting and so forth. That's when you get into all the surrounding components and functionality that we know is truly needed. And so we talk a lot about speech to text. The name of the system here is Symphony for speech to text, but just that last reminder that there's more to it than that. And when we get into the details of what problem are you trying to solve, that's where you want to understand which API is correct for my needs, and then how do I configure that to solve my actual problem. And so maybe with that, Garrett, if you want to go into the next section, we can talk about how do you actually use Symphony for speech to text.
Absolutely. And first and foremost, thank you all for popping questions in. When we get to the end, we'll make sure that we resurface a lot of those questions. So I promise I'm seeing those, and I think a lot of them are good conversation that we'll have here shortly. So as Dan mentioned, now that we know how accurate the product is, let's talk about how we can incorporate these models into your solutions. So as Dan already highlighted, we want to talk a little bit about the speech recognition endpoints available in Corti's API. As he noted, we offer 3 different endpoints across which you can accomplish what you need for speech recognition. The first 2 being real-time to help give users real-time results from speech, and the last one being more asynchronous, more of a batch processing kind of approach there. So transcribe is the endpoint focused on real-time dictation workflows. It's stateless, meaning no audio is retained from its use. In addition to specialized medical speech recognition, the endpoint supports dictation features like spoken punctuation, commands, and much more. Streams is the endpoint that helps with real-time ambient workflows. So that Streams endpoint contains that same high-quality medical speech recognition tuning, but additional features that support those ambient workflows. Features like fact extraction allow for clinicians to focus on the patient and the conversation and know that at the end they will still have a highly accurate transcript and a list of medically relevant extracted facts. Again, finally, that transcript endpoint supports organizations' asynchronous transcription needs. It features most of the same features previously mentioned on those other endpoints, but works off of supplied recordings for transcriptions. We see organizations using this endpoint either for bulk processing and analysis of audio or to support their applications that may support more rural or remote populations where that network isn't always guaranteed. We're talking a lot about dictation today, so I'm going to kind of stay on that path. And so for the purposes of dictation, we highly recommend exploring that transcribe endpoint. As previously mentioned, this is a stateless endpoint that produces a real-time transcript as the user dictates, which allows them to see real-time results. On this slide, I want to talk about a few of those features and what they do before getting into more of the considerations and using each of these features and other features that I also have on the next slide. So kind of going down the list here, interim results is a really good feature to show the work in progress transcript. So it will return those real-time results from that current context window to ensure the user is able to see the transcript just a little faster as they speak. Spoken punctuation matches many dictation workflows, right? Period, colon, new paragraph. The feature allows for providers to continue to use speech and not mess with post-editing to make sure that their dictations are readable and clean. Commands similarly help clinicians to keep their hands free during their workflows. Many organizations use this to navigate through interfaces, select and edit text, and again, keep their hands free during those workflows. Lastly, formatting is especially important in healthcare documentation. It's also especially important to providers if they want numbers and they want to see that number, that they see the number. If they want measurements like milligrams to show as mg and not written out in full, that they'll just see mg. Formatting lets you make sure that your users see exactly what they're expecting to see. I've talked about a lot of these just in that last slide, but just a few kind of downloading my brain to you, tips and tricks to make sure that you understand kind of how some other organizations are engaging with some of these different functionalities. So first off, interim results. I absolutely love this feature. So please use it. Please use it. It shows that provider that really fast transcription, right? So you get something returned to you quite fast. The one note, just make sure you update with that final transcript as that context window closes, especially for any downstream workflows. We'll see what that looks like in the demo here in just a minute. That transcribe endpoint allows for spoken punctuation or automatic punctuation. So I'm just kind of going down the list here. For dictation purposes, I always recommend spoken punctuation. That's just maintaining parity with what most dictation devices and offerings offer there. When it comes to commands, start small and use tooltips to indicate what's available. I've seen many organizations go very broad with lots, and really that just ends up confusing providers and adds to frustration if there's too much and they can't remember exactly what the various nuances are across those commands. So start small, indicate what's available, and measure what's adopted and used, and just expand from there. Just so that's one word from our experience there. The next one I didn't actually talk about on the last slide, but I'm very excited to talk about it on this side. We return audio events in our WebSockets, and I think this is so incredibly important. So what you're going to learn later on in the slides is that about 40% of the speech recognition issues that we receive is just due to not ideal audio. So using audio events will allow you to surface issues with incoming audio directly to end users. So that could be that their mic is across the room. That could be that their mic's sitting next to a fan, certain things like that. It allows you to help the end user to make sure that they're using the right mic, that the mic placement is good, and that ultimately that they become part of making sure that they're delivering good audio quality to you. Lastly, formatting. Everyone has a different definition of what they want. use this to support more end user configuration and allow your users to determine their ideal output. So that's typically what I recommend folks do from a formatting perspective. All right, all of that considered, I think it's important to show and not tell. We're going to jump from slides, and if you attended our last webinar, you know I love a good demo app. The twist here is this app is actually available for you to test on our website. So from the Corti website, under resources, we have this lovely tool, Compare Speech to Text APIs. With that open, I'm actually going to stop share and reshare just this tab to hopefully make sure that you can hear the audio when I start to click and let the audio fly here. So give me 2 seconds. All right, we are back. So before we get started, some quick navigation of the application. First, when you first use this, you'll be asked for microphone access just to make sure that you're selecting the right microphone, right? And that's going to be here, but you're also going to be asked to access from your browser. So just making sure that you grant that access so that we can hear what you're saying there. By default, what you'll see is Symphony here in the middle frame, ready to transcribe whatever you throw at it. Along the left-hand panel here, we've integrated other speech-to-text vendors to allow you to compare performance for yourself. We have some pre-configured voice commands also for demonstration purposes. You'll see in this demo here that we've got a number of commands that we kind of utilize throughout that with spoken punctuation. And the last thing that I want to highlight before I get to the demo, you're going to notice that we have chosen in this app to represent interim results for this application. So interim results will appear in kind of italics in a lighter color, like a grayish color, and will adjust to non-italic black text when that final flag is returned. So what we're going to do now is, rather than have myself dictate and fumble over medical terms, because while I've been in medical software for a large part of my career, I'm not good with medical terminology. I'm going to go ahead and select one of the predefined dictation within the application, and I'll just stay quiet and we'll listen to that, and we'll just kind of watch this in real time transcribe the recording there. So I'll go ahead and hit play and we'll be off to the race.
MRI brain with and without gadolinium contrast, comma, with MR spectroscopy, period. New paragraph. Clinical history, 71-year-old male with intermittent headaches and progressive left-sided weakness, period. Prior history of stroke, period. New paragraph. Findings, there is a spherical lesion measuring 0.9 centimeters at the right subcortical occipital lobe, hypointense on T1 weighted images with a hyperintense rim on T2 weighted images and ring enhancements on post-contrast sequences, period. Blooming artifacts is noted on susceptibility weighted imaging, period. No restricted diffusion on DWI or ADC maps, period. New paragraph. These findings are consistent with granular nodular stage neurocystic hysterosis, period. Additional lesions are identified at the left juxtacortical temporal lobe, right juxtacortical parietal lobe, and left thalamus, the largest measuring 1.2 centimeters, period. These demonstrate T1 hypointensity, T2 signal void, and blooming on SWI without contrast enhancement, consistent with nodular calcified stage disease, period. New paragraph. MR spectroscopy of the right occipital lesion demonstrates decreased N-acetylaspartate, choline, and creatinine with elevated lactate and lipid peaks, period. NAA to creatinine ratio is 0.38, period. Choline to creatinine ratio is 1.21, period. Both ratios are below 1.5, favoring neurocystic hysterosis over tuberculoma, period. New paragraph. Impression: multifocal parenchymal neurocystic hysterosis involving granular nodular and nodular calcified stages, period. No evidence of hydrocephalus or midline shift, period. Recommend a correlation with serology and infectious disease consultation, period.
All right. Look at that high quality transcript. So what you likely saw as you followed along on the screen was, again, those interim transcripts would sometimes update when it moved to final as that context window expanded. And what we're left with is a transcript with the formatting that was dictated in a nicely presented note. So you heard a very familiar voice say things like colon, new paragraph, and that was very much reflected in that final documentation. I'm going to get back to this in a little bit, but I wanted to first share the dictation demo just to show some of the results. I'm again going to reshare that full browser window because I'm going to bounce around between slides and this in the near future. So I will go ahead and share my screen again, and we will get back to our regularly scheduled programming. So we have a transcript from a recording. How do we tell if it's good or not? That's the $1 million question that we want to answer here. To help in your evaluation, we've made available some open source libraries to make this either easy to build your own evaluation tools, or you can just use ours because we just saw that on the screen there. We have beyond word error rate is kind of what that first one is. It's pronounced Beaver. This is an evaluation and analysis framework for ASR. We also have Error Align. This is an alignment algorithm that improves on simpler tools that have simpler tools where you see one error in transcript kind of cascading throughout the evaluation inappropriately and really putting a knock on word error rate and character error rate inappropriately. And lastly, we have Corti Canal. That's a package around a lot of these frameworks. All are available on our docs page and within GitHub. To navigate that real quickly, within docs in speech to text, and we'll make sure that we send this in the follow-up there. We have performance evaluation, which within this page links out both to Error Align as well as Corti Canal, which will link out to GitHub. So those are all made available to you. Again, we saw that we also linked this on the website to make sure that you can get to that much easier. All right. Even with these tools, evaluating an ASR is hard. So I don't want to sound dramatic, but we have the data to show that many people fail in those first attempts to evaluate the quality of a speech rec model. Before this, we pulled a report of all of our speech recognition related tickets, and the numbers kind of show the following. So 40% of tickets reporting a suboptimal transcript are actually due to poor audio quality. So the actual cause of poor audio can vary greatly, and we'll talk about that here in a second. But a lot of those common factors include using a dictation mic for ambient use cases or vice versa, right? And so if we're dictating but using an ambient mic, we're often picking up audio from elsewhere within the room, and especially if this is in a busy ER, for example, we're actually transcribing everything that's being said, but also by other people. Dictation tends to be much more directionally speaking, and so choosing the right mic for your use case is very much critical. Mic placement is also quite important. I mentioned this a little bit before, but we've heard many audio samples where the mic is sitting next to a fan, it's on the keyboard while someone's typing, or it's just on top of a noisy machine that's causing for a lot of that noise to be buffered out. The last is distortion in audio transit. We've seen some organizations where they transform that audio before sending to Corti for processing. Ultimately, some of that processing before it hits Corti results in the model receiving something that's very brown noise at best, which again is very hard to transcribe at a high quality there. Assuming we've got good audio quality, and that's high quality, another 30% of those evaluations have failed in that evaluation stage. Where we've seen struggles is in configuration and in the gold transcript. For example, if your gold transcript spells out milligrams, but your configuration is set to abbreviations, you'll see that reflected in the word error rate, even though it was correctly transcribed. Lastly, we do see some evaluations resulting in the need for a model update from Corti. As you heard from Dan, we can do that pretty quickly. So we're here to help as you get to evaluating. And so as you do any of these investigations, if something seems amiss, reach out to us and I'll kind of speak to later what exactly we need from you to help dig into this with you. But we're here to help. All right, back to our demo. Let's walk through these steps with that previous example that we shared. So we just said in kind of our tick list of things we need to be working through that audio is very much the first thing to check. So you know from the audio that we just gave in this demo that the audio was actually quite good. It was clear, we could understand it. There was one instance where the narrator said creatine, but corrected themselves to creatinine, but the audio was clear, right? So it's pretty safe to rule out that we're not the victim of poor audio quality with this test. For your use cases, make sure you map out those retention policies, know where the audio lives to be able to extract that if you have any issues that are reported. But ultimately, for this one, we can check off audio capture because we know that we've nailed audio capture, that's quite good, and what we sent over to the model was quite good. Next, we said we needed to look at what we're expecting to see. So recall that our demo app illustrates the way that the WebSocket is configured and shows the configurations for the WebSocket. So for this demo, we know that spoken punctuation is active, that the abbreviations are configured. You'll also see some spoken commands that are baked in there, but we don't necessarily evaluate on that in this particular case. We'll use this configuration to iteratively ensure that our transcript is indeed a gold transcript, but by and large, we can go ahead and check off that we've configured the WebSocket appropriately. So we've got good audio. Now we know how we've configured the WebSocket. Now's the fun. We need a gold transcript. I'm not going to sit here in the last 13 minutes of our time together and show you the full process of me listening to this and writing down exactly what was said from a transcript perspective. What I did actually ahead of time was produce exactly that, a gold transcript. So with exactly what I hear, I'm going to go ahead and write this down. And what you're seeing reflected in this gold transcript is where spoken formatting words were used. I've made sure to reflect that in the transcript. So where comma was said, the punctuation mark of a comma is reflected rather than me fully writing out comma, because again, we've configured the WebSocket to have spoken punctuation, so it's going to go ahead and convert that over to a comma. Same thing for colons and other formatting. So I go ahead and paste my gold transcript in here. I'll go ahead and click done. Within this application, I can then click diff. What diff is going to do is it's going to take that gold transcript and it's going to compare that against the transcript that was output by the by Symphony, and it's using those kind of previously mentioned methodologies, right? So we talked about Beaver, we talked about Corti Canal to evaluate the accuracy of the produced transcript against the gold transcript. You can see from the example, the differences were quite minimal. I mentioned before that in that recording, right, we said creatine, but then quickly corrected to creatinine. The model itself wrote creatine, but the gold transcript, because there was a correction to creatinine, I went ahead and updated that. Once you have this diff done, you can also use this to produce a report. And this will utilize a lot more of that Corti Canal technology to generate a professional summary of the material so you can show the accuracy of your test. So I'll go ahead and click this report button. What that's going to do is open up in a fresh window more of a PDF-able version of this. And we can see that for this transcription, for this dictation example, we have a word error rate of 0.5% and a character error rate of 0.2%. That's it. So it looks, I know I made it look quite simple. It is much more complex. That's a lot of staging that I've done ahead of time, like making sure I have the right audio or the right gold transcript put together. But that's in its core, the steps that it takes to evaluate the success of a speech recognition model. I have a few slides that I'm actually going to skip over in interest of time here, but they include examples of poor audio, incorrect evaluations, and just other pitfalls. So we'll make sure that we send the full the full slide deck after the fact, but you'll see that we've got some recordings. If I'm actually sharing my right screen, we've got some recordings here of suboptimal audio, in addition to other evaluation criteria that might kind of trip over itself. So when you go to evaluate quality, be sure of the following: your audio is correct and valid. Even internally on our side, we've identified it. So yes, that's something that we want to make sure that you've got at your disposal. So last note on evaluation, sorry. If you're running into challenges with your evaluations, we're here to help. If you need help, please send the following to help@corti.ai along with a summary of any challenges that you've run into, and we'll help. So audio samples, anonymized if it does include PAI, just for kind of data sharing best data sharing practices. that gold transcript that you've created. The configuration payload code snippets very much help. And if you're using any particular testing methodology, send it our way, and we can make sure that we're helping you to evaluate that and digging into where things might be what might need some help there. All right. We always want to end on a high note, so I'm actually going to pass things back to Dan and let him brag a little bit more about what his team's been up to and what's available now and what's kind of coming next.
Absolutely. Thanks, Garrett. And yeah, the evaluations are complex and difficult, and but doing it at that level of detail, I think, is necessary and helps identify the specific areas that are problematic on either side of the setup, the testing, the evaluation, or the model and the performance, and then we can engage on how to make it better. But like we talked previously about, the speech to text model itself is step one, and then what you do with the downstream output is also really important. And to augment that downstream processing, there's two features that are coming out very, very soon. Replacement rules are in our internal staging environment, undergoing testing and getting ready for release, hopefully by the end of this week, where you can define one word that should replace another, very akin to a find and replace. This is useful for standardizing terminology across an organization. If there are best practices and documentation that you want to enforce, or if clinicians want to set up their own preferences, you can use a replacement rule so that you get output in the way that you want it and not necessarily how the system delivers it. That is complemented by a custom dictionary term feature where you can also define terms that the system is unable to recognize reliably. This is also important for terms the system is likely not aware of, like proper nouns, surnames, building and location names, things that are unique to your facility and organization. You can define those as key terms or terms in the configuration, which will help bias the system. It also helps with coin flips. There are some scenarios where the context is ambiguous, and there's a lot of homophones in medical dictation and documentation. And so defining terms can help to bias the system in the right direction based on what your individual clinician or organizational preferences and patterns are. This first release of the dictionary terms feature in the next couple weeks here is just step one as well. There's a roadmap specific for that area of the business where we want to expand what you can do with the terms that you're defining, as well as introduce a broader system vocabulary. And if you go to the next slide, please, that'll round out where we're going to go next. And so, firstly, the contextual correction is exceptionally important. You'll see on our roadmap, this is listed as this post-processing engine to help catch grammatical errors, potential spelling and homophone mistakes, and other context-relevant things that you want to post-process and review in broader context than the real-time speech recognition itself. And so our contextual correction engine, we have parts of that running already today in production, but there's still more of that in development that we're looking to release in June to round out that overall post-processing performance and functionality. Initially, this is all kind of baked into how the model performs, but in time, we'll be exposing more configuration controls so that you can drive what that context and how those corrections work. The vocabulary is one piece of that. And so being able to bulk upload system vocabularies, if you want to, again, control the terminology or augment the terminology as you need it for your organization, but you'll also be able to query the vocabulary the system is trained on so that you know if it knows a word or not. And if you query the system and identify that this word was in the training, the model is aware of it, but it's not being recognized reliably, very useful feedback we'd love to hear. Because then we can dig in and understand, causes, context, and things that lead to it not being recognized reliably. And then we can target that for improvement, which is obviously very different than, the system doesn't know this word at all. It's not in the vocabulary. There's a different approach for training and teaching the system that new word. All of that builds up to where we go next in the broader terms. So we've talked a lot so far about our three endpoints for real-time streaming, for transcription and dictation purposes, or for conversational ambient scribing workflows. We also can do batch audio file processing for any variety of workflows. But where all of this is going to go as an industry is to not just speech enable the user interface with transcription and a dictation app, and not just transcribe and scribe the conversation, but to make a wholly driven speech enabled experience, to have a conversational agent that can parse requests that are not predefined as commands, to identify the intent of what's being requested, and to link into our agentic framework to automate workflows, in a much more comprehensive manner than you can do with a command in and of itself. And so that's kind of the next frontier. And we'll welcome you back for a webinar, hopefully this fall, this winter, on what we do in the world of conversational agents, as that'll be that next major step forward in how you use speech recognition in the world of medical documentation and beyond documentation, right? Not just to navigate and speech enable the chart, but to build out, smart speech-enabled rooms in health systems, and to support patients, right? There's so many other places to go, because I think speech and dialogue is what provides the best method for semantic interoperability that we know healthcare really, really needs and is constantly looking for. So exciting frontiers ahead, and this launch from last week is a matter of setting the baseline, which we are excited about continuing to improve our performance upon. I think with that, Garrett, that was probably our last slide right under the wire. Maybe we have a couple minutes for a few lingering questions before we wrap at the top of the hour.
Yeah, and for those that have written in questions, we'll make sure that we share out in our notes the full kind of write-up of each of these questions and answers to each of these. So thank you so much. This is very helpful. We'll make sure that every single one of you gets an answer. I'm going to bounce around and maybe choose a few of these that I think is going to be shared across a lot of folks, and then we'll go ahead and wrap this at the top of the hour. The first one in particular, Dan, that I think is quite important to touch on is this available in the console itself? And also, do organizations need to do anything to switch over to take advantage of Symphony for speech to text?
Yeah, let's clarify that point. So first part, yes, you can go into the Corti API console and test both dictation or ambient conversational speech to text. And so there are now two different tabs in the studio where you can test it out. And what I love about that studio is as you test different configurations, you can also get an export of that configuration to bootstrap your application and get going. We also have agent-driven starter sets, if you will, to build apps really, really quickly that have been updated in our API console. So yes, they are available today. And the announcement from last week was just the publishing of our latest benchmarks and performance and establishing this baseline. So if you're integrating with our API before the launch, no change, nothing different needed there. It's just us putting that stake in the ground of our latest evaluations and being ready to communicate more broadly about what we're seeing and experiencing, and then ultimately releasing the data sets to support that transparency and reproducibility across the landscape.
Awesome. All right, this is probably the last one that we have time for, but I think this is also important for us to touch upon. Folks are wondering about the comparison approach. So is there a particular reason that Corti's being compared more with AWS and Google versus maybe some of more of those application layer solutions, such as a Heidi, a Suki, a DeepScribe, a Bridge, so on and so forth?
Yeah, thanks for raising that one. I think the key detail is that those APIs are with whom we directly compete. And so an app like a Suki or a Bridge that's providing an AI scribing product, while Corti does offer a fully packaged ambient scribing Corti Assistant that can also be modularized and embedded into your own product and white labeled, those AI scribing products would be secondary to the raw speech to text engine itself. And so we are benchmarked and compared to those that would be similar with whom you can integrate for building an app yourself. And if you need support and getting into the differences on those two sides of the fully packaged application versus the component of the speech to text, please reach out. Let's engage in that level of detail. And if you're with one of those companies, we'd love to power, obviously, your AI scribing apps with our speech to text, and would love to hear what you're experiencing with one of the other big box players. And I think we can have a conversation about opportunity for improving upon what they may be able to support.
Amazing. That brings us to the top of the hour. Thank you all so very much for joining us today. This has been a lot of fun. What I'll do is I'll make sure that we take down all of those questions, and we'll make sure that you get answers as a fast follow to this meeting. So thank you again. We'll send the recording, we'll send answers, we'll also send the slide deck. Very much appreciated, and have a fantastic start to a short week.
Thank you.